Hello all. So this video will be quite short because it comes immediately following the previous lecture I gave on making the Canada census data uh, visible so that we can use it. And so this is going to be the start of the use of this data in a context of what are called linear least squares. But this means that the beginning of the lecture will be short because I don't want to overrun the 1 hour 15 that we have for the combined lecture time. Okay, so this is just in passing. Some of you might be interested by this. I've made a notebook that I will be putting on the web, on UofM Learn, and you'll see that we can actually make slides in a Jupyter Hub. This is actually quite nice. I did not know this. Let me make this full screen. This doesn't look like slides so far, but what I've done is in the edit, no, not edit, view. In the view thing here, I've selected slideshow. And when you select this, you get these little boxes that appear on the side here, where you can attribute a value, let's say a type of object to a given cell. So this cell, for example, I'm saying slide. What this means is this is going to create a new slide. So whenever I have slide here appearing on the side, it's going to be a new slide. Whereas here, for example, you can see I have a text cell that I've designated as a slide, but this one is not a slide. What that means is that the this slide here will contain that content as well. Okay, so without further ado, let's look at this. Okay, so to see it, you can hit this here. Enter, exit, rise, slideshow. Wait, before I begin, let me run all cells. This way the text is rendered everywhere. So hit this, you go into slides. Oops, of course, I have to start at the beginning. For some reason, it went to the end. Okay, so you see we have a slideshow. You can then move around with your arrow keys or enter, etc. The cool thing, just in passing, is that this is still Jupyter. So I can actually edit my slides as I go. You see, I can add things, and then when I evaluate the cell takes on this new content. Okay, so this is quite cool. So least squares. So this is really, we start with the content, although we'll still be doing a lot of computer use. As I indicated, this is very important in this course, and therefore we will throughout the course be going back and forth between mathematical presentations and computer-based presentations. So what is least squares about? So to sort of situate the topic, I'm going to start with the following running example. So in the previous video, I showed you how you would use R to gather data from the internet, in this case, Stats Canada website, and to assemble this data into a usable form. And so what we did is we picked up the census data for Canada since 1850 something. And now let's load it. So remember, I said read CSV, reads a CSV file. If you recall in the last video, the last thing we did was to save the result of our queries into a CSV file. So all I'm doing here is reading this file back in. And I'm just going to plot this data. So we've seen that last time as well. So I just plot the year, the population, both types of output, so line and points, line width of 2, and I put labels year and population there. And just a remark in passing, as data scientist oriented people, it's always good to plot the data if you can. I mean, there are instances where it's difficult to plot the data because it's just absolutely huge. And there's a whole branch of data science which deals with data visualization, where they consider this type of problem. But if you have something that is simple, always plot it to see what it looks like. Okay, so what we see here is, well, an evolution that seems to go through three phases, essentially, until the early 1900s, and then somewhere mid 20th century, and then since the 1950s, essentially, we have this increase. And the question is, well, suppose I want to use this to try to predict what the population in Canada would be in 20 years. Okay, we've got this growth curve, and we're thinking, well, if things remain more or less the same as they have been running, what population can I expect? And I mean, as a politician, as a decider, you'd have to take decisions in terms of, I don't know, healthcare, a variety of topics. And so it's important to do this. Okay. Now, if we had just 2 points, if our data, instead of being these, I did not count them, but 25 or so points, if we just had 2 points, it would be very easy. Okay, I can drive a line through the 2 points. It's going to be simple. Now, where the problem arises is, like in real life, it's very rare to have just 2 points to deal with. We typically have a lot. And so what we are going to do is we're going to, instead of trying to fit a line through all the points, we're going to try to get a line to go through all the points. We're going to try to make a line that actually comes as close as possible to all these points. Okay, and this gives rise to what we call linear least squares. Okay, actually, let me edit this as we go. I don't need this. That's it. So let's look at linear least squares. So let's start sort of setting up the problem. So let's start with the case I was talking about just right now. So if we have 2 points, what can we do? So I'm going to use this also as a means to show you some R and some programming as we make our way through the topic. So here what I'm doing, points equals list. I'm declaring that points is a list, and lists are the basic way of evaluating, of storing, well, they're not a basic, but they're a very simple way of storing information in R. Those of you who have experience programming in other contexts, such as, for example, C or MATLAB, those would be structures. In R, the equivalent of a structure is essentially a list. There are differences, of course, but the idea is about the same. And so a list is a very, very versatile data type, because we can put essentially all we want in there. Things don't have to be the same type for all the elements in the list. Things can be named and etc. So what I'm doing here is I'm creating two elements in the list. And here I'm making them the same type, because what do I want to do? I want to create 2 points. So I'm going to put their x coordinates as x and the y coordinates as, unsurprisingly, y. So the 2 points are here, and I can access them by using this dollar sign. Okay, remember, this is actually the same thing we did in when we were using a data frame. So the way of accessing the points is the same. So what we've made is 2 points, the one that has x coordinate the first entry and y coordinate the second entry, and the other that has first coordinate this entry and second coordinate this entry. So our points are 1, 3, and 2, 5. And note, I will put some remarks here and there, and that's it. So here I'm just going to plot these 2 points to illustrate things, and I think that will take us to the end of this video. So how do I plot this? Well, I'm just indicating these are points. Because they're like this, I don't need to say that I want to plot points. Okay, so the type can just be left empty. PCH equals 19 that you see here means that I'm making a dot. Okay, if I used another, let's say PCH equals 21, you see the PCHs give you a variety of things that you can plot, and there's smaller ones, okay, PCH equals 1. I mean, there's a lot. 19 is good because it's a filled circle. CX equals 2 means that I'm making the points a bit bigger. The default is CX equals 1, and you can't see much. I could make them huge by changing this parameter. So I'll just stick on to 2. Let's say it makes them visible without being fantastically large. BTY equals N means that I'm not putting the entire box around this. Okay, so if I here comment out this, you will see that I end up with the box. If I uncomment it, I end up with this axis type. Finally, I'm going to put some limits on x and y just to say, well, I want a bit more, because if I don't impose them, it will plot for the data. So it will plot from essentially a little before 1 to a little before after 2 in x, and a little before 3 to a little after 5 in y. I want to make this a bit bigger, so I impose this. And that's it for this video.